Welcome to solverfy.
So in this problem, we are given two drums, B and C. B has a radius of 20 millimeters and a moment of 0.3 Newton meters and a force of TA on the left. And C has a force of P on the right, and we're given the static coefficient of friction to be 0.4 and the kinetic coefficient to be 0.3, and we're asked to determine P, where slipping in B will not occur. So let's break this down into the two free body diagrams of wheel B and wheel C. So we have B over here, there's a force TA downwards, then another force, we'll call that TB. We have an angle of pi between the 2 points of contact. The radius is 20 millimeters or 0.02 meters. And since we're looking for the case where slip will not occur, we'll use the static coefficient of friction of 0.4. And we also know the moment is 0.3 Newton meters on this wheel. And then we have C, where we have a force of P on one side and a force of TB upwards. So let's use this to solve for P. So given our free body diagram of B, we'll take the difference between the tensions times the radius to be the moment of 0.3. So we get TA minus TB is equals to 15 newtons. And that's our first equation. Now for our second equation, we use impending slip. So we have TA to be the higher force because the moment is in this direction. So we have TA over TB is equals to E to the angle, which is pi, times the static coefficient of friction. And so TA is equal to 3.513 TB. That's our second equation. Now we substitute that back into the first equation to solve for TA and TB. So when we substitute that, we have 2.513 TB is equal to 15 newtons. So TB is equal to 5.97 newtons. And TA is 15 minus 5.97, that's equal to 9.03 newtons. Now we go back to C, and we see that C is free to rotate in any direction. And we have the force of TB on one side and P on the other side. So since C is free to rotate, and we're looking at impending slip on B, we basically have P to be equal to TB, which is equal to 5.97 newtons. And that is our answer for this problem.